Okay, let's start the session. Okay, so everyone are able to see the screen, right? Hello, can you all hear my voice? Okay, thank you. Fine. So yesterday we have discussed about computer system languages, environment, and your system development or software development life cycle. Today we are going to talk about creating and running programs. Okay. So understand here, we have different phases where we create and run our programs. So what is this creating and running programs is nothing but you all know that your computer system understands only nothing but your system hardware. Either it is a mobile phone or it is a laptop or desktop. Any electronic devices or any hardware devices can understand only one language, that is nothing but you will call it as machine level language, right? So now what is this is we should know how your program or your set of instructions will be converted to machine level language or machine understandable language. So generally any compiler or any programming language follows these basic steps in order to compute a human instructions into machine instructions. So there are four phases generally which we do. So the first one, we call it as writing and editing programs. The second phase of we are going to call it as compiling. Then we are having the third phase as linking. And the last phase of your program completion is nothing but executing. Okay, so generally this creating and running programs, okay, how do you create your programs and how do we run your programs involves these four basic steps. Why do we need these basic steps is, so whenever a human, that is nothing but whenever an user is going to design his instruction set, it have to be understandable by your machine, that is nothing but your hardware units. So in order to convert these instruction set to machine readable form, we are using four basic steps. The first basic step is nothing. Dev C, or it can be a C compiler, or it can be any other code blocks anyway. So that the platform where we design our instruction set, we are calling it as a text editor. So it depends. This editor changes from one programming language to another programming language. Okay, like Java, you can write it in Notepad. You can use your Eclipse Notepad, or like if you take your Python, you can do it in Jupyter. Anyway, right? So whatever the instructions a user is going to divide, I mean, is going to write, those instructions will be designed on text editor. After your instructions are being designed by the user, okay, you will have to store these instructions. Like how you have to design is this. Why do we write your programs first of all in text editor is because it's capable of creating your program not only you write your program, it also has a facilities like you can search, you can locate, you can replace, you can copy and paste. So all these things that can happen on your text editor. That's the reason we design our programming on text editor. Now once after your instructions are been designed by a user, now what we do is the first foremost step is to convert your instructions, that is from a high level programming language to machine readable form. Okay, so that phase we are calling it as compiling phase. In this compiling phase, we have two separate programs where we have two things. So this compiler will have two things. Okay, 1 second. So the second foremost step is nothing but I'm calling it as a compiling, and you will be using a compiler which is acting as a translator. This compiler has two separate programs. Okay, generally your compiler will have two separate programs. One is a preprocessor and the other one is a translator. Okay, so compiler will have a two different programs. In compiling phase, we use compilers where you convert your source program into machine language. Okay, your source program can be high level language or it can be assembly language. So anything, your compiler contains two programs. One is preprocessor and the other one is translator. What does a preprocessor does is our thing. So what does a preprocessor do is, preprocessor always reads a source code and it prepares the conditions or it prepares the instructions for translator. Remember one thing, preprocessor is helping you to read the code. After it read the code, it creates some instructions or it creates some program again, and that program is ready for your translator. Like for example, you have used some printf method to print hello world. Now in order to access the functionalities of printer, you include your library functions like hash include stdio. That is a preprocessor command. Now, what does the preprocessor do? Before it submits this program to a translator, it will include all your library functions which are ready, which are needed for your line of code to be executed. Okay. Now, when you write that, what does the so only one thing you need to remember, preprocessor always will read the source code and it will make a program ready, which is submitted for the next thing is nothing but translator. So when a user writes a program, okay, suppose I have written a simple statement like printf, some message. When I write this and when I go for the compilation, like I have message called as hello. Now when I write this line and immediately I can't go for conversion. I need all my libraries which are needed to run the command printf. So that role is played by your preprocessor. So preprocessor will read all the code. Then after your code is complete, then that code will be given to your translator. Now what does the translator do? Now once your code has been ready for your compilation, translator starts converting the program into machine language. Okay, translator always receives a program ready for translation. Okay, preprocessor will make a program ready for translation and translator receives a program which is ready for translating. Now, whatever the instructions you receive, like if you take your C program, it is high level language. Now, your high level instructions will be converted into machine language with the help of a translator program. Okay, you'll be having a translator and it is going to convert. Now, obviously, after you convert, so basically, let's say I have a simple program hello.c. Hello.c is a file that has been created on my text editor. After my program is been successfully completed with pre-processing phase and translation phase, then this hello.c program will be converted into hello.obj. Okay, so all what happens once your once your hello.c is been once your hello.c is free from converting from high level to machine, that is after you include your preprocessor commands and your translation phase is done in compiling, then it will create .obj file. It's nothing but an object code. Okay, you'll be having your object code ready. Now once your object code is been ready, now what we are going to do is we are going to create a module that is nothing but another fun that is nothing but a linker. A linker also will come into existence. Okay, what does a linker do? It will just assemble all the functions and converts the object code. Okay, so in compilation, you will generate an object code. When you submit this object code to your linker phase, what does it do? It is only going to combine, or it is going to assemble all the functions, and it is going to convert that object code. Okay, again your object code have to be converted to executable code. So when you are executing the program, okay, when you are going for the execution phase, executing the program, that is the fourth phase. When you are going for the executing phase, okay, when you are going for the executing phase, what does we do? That is, it's nothing but a runner. Okay, runner is nothing but your executing phase here. In executing phase, what we do, your once your program is linked, it's ready for execution. In executing phase, your program is ready for execution. What we do is, we will move your program onto memory. Yesterday I have told you. So remember one point, you have your secondary memory and you have your main memory. All your first instructions, that is nothing but a normal program, is on secondary memory. Your program have to be moved on to main memory, then only it is ready for execution. So a program have to be converted to a process. So if a program is converted to a process, then only you can say that your program is under execution now. So once your program is under execution, now you generate .exe file. Your .obj file will be converted to .exe file. Then the last phase is you will be having your output printed. So these are the four basic things that is going to happen. Okay, one second. So once again, I'm saying you. So whenever you are creating and running program, or whenever you are creating and running programs, what is this creating and running program is? First, we have to understand why do we go for this creating and running programs is, all the instructions that are designed by a user, it have to be converted to machine understandable language. In order to make your machine language code, we make our program and go under four basic steps. The first one, we are calling it as writing and editing. Okay, then we are calling it as compiling. Then we are calling it as, the next one is as a linking, and the fourth one we are calling it as a executing phase. So these are the four basic steps that are involved in order to make a user program to be converted to machine readable form. Now what is this writing and editing phase is nothing but, you are going to use a text editor where we create a user set of instructions. That is nothing but a user program will be written, or your software, a simple set of instructions will be designed on your text editor. Why we are using text editors will have a capable of changing, modifying, updating, replacing, deleting, all this. So in order to achieve those functionalities, any programming language uses text editor. But this text editor is different from one platform to another. Like for C, we use different for Java. Now, whatever the instructions we design on text editor, they are been. For example, I have written a program hello on, if it is a C file, I'll stay with an extension called as hello.c. Okay, now what we have to do, once your program is, once your designing of instructions is ready, after you save, then we go for the next phase. It's nothing but compiling. During compiling, we use some translators, yes. So we have something called as compiler, where we have two things in your compiling phase. We have two programs which are run parallelly. That is nothing but, the first one is preprocessor program, and the other one you will be having it as a translation or translator. So first your programs will be not directly converted to machine understandable. First your program, whatever your preprocessor will read the source code, and then it prepares it for translator. Preprocessor is going to read your program, like hello program will be read by preprocessor, and it will make the piece. The last phase is executing the program. That is nothing but, you're calling it as a runner. Okay, in executing a program, what does we do is, remember, whenever you save your file, you will be storing your instructions on secondary memory, but you can't that execute secondary memory, have to be loaded onto main memory. Your program from secondary memory will be loaded onto main memory, and now your program is under execution. That is nothing but it is a process. So we can't call program under execution until it is moved from secondary memory to main memory. Once your program is loaded onto main memory, then your execution phase happens where you generate .exe file, that is executable code. Are successfully created, then you get the final result, that is nothing but your output. Everyone understood with this? Anyone has any doubt with how to create? So remember one thing, this is creating and running the programs. Anyone has any doubts with this program? I mean these four phases of your programming? Hope everyone understood this concept, creating and running program. Yes? Okay. Okay. So next we will move for the next concept. So listen here, we have done with creating and running programs, SDLC. So we'll talk about algorithm and flowchart. Okay. So fine, I'll complete that only. So what is this algorithm and flowchart? We'll understand. So you'll be having expected some questions on algorithms and flowcharts. So first I'll complete that. So algorithm. So generally I told you yesterday that when you are talking about software development life cycle or system development life cycle, the first one is requirements gathering. The next phase is your analysis phase. In analysis phase, what we do is we keep our ideas in the form of English in the form of understandable language, that is according to the different user. So we will be writing some instructions which we can understand. So algorithm is nothing but you call it as a step-by-step procedure to perform a particular task. Okay, it's a basic definition of algorithm. Understand? So what is nothing but, suppose if you are given some program, let's take you want to find I'll write a simple program. This is some expected question. Like they will give some question and ask you to design algorithm and flowchart. Area of a rectangle, let's take for example. It's a small program, I'll explain you. So you should know. So what do we do in algorithm is we are not writing any, we are not going to use any programming language to implement that line. First in algorithm, what do we do is we are going to analyze what are our requirements and how do we want our program, what is your input, what is your output, and what should be your expected output. So that step-by-step procedure, in order we are calling it as a algorithm. Now, the pictorial representation of algorithm is nothing but you are calling it as flowchart. Okay, if you convert the pictorial form of your algorithm, pictorial form of algorithm is nothing but you are calling it as a flowchart. Okay, now what is this step by step? You understand now? We'll see here. So first we'll see how to write an algorithm. So your question is you are finding an area of a rectangle. Okay, so first before start you have two things here. You will be writing all the statements in the form of English understandable form. Okay, your algorithm will include all English understandable form. So you all know that how many inputs we need is the first thing you should remember, and what are your outputs readed, and what should be your computation statement is your thing. So in order to find your area of a rectangle, we need two inputs. What is that? One is a length parameter and the other one is breadth. Finally, your output is nothing but you are finding your area of a rectangle. And you know what is the computational formula for area of a rectangle? How do you find area of a rectangle? Hope you all know that formula. You write area is equals to length into breadth. We know this. Now this, in order to make any another person who is going to, who is going to execute, who want to see this algorithm and to create his own program, he should understand your procedure. So the first steps, you will write it as step 1. So the first, you can call it as start phase, or you can also call it as a begin node. Okay, then you'll be having your step 2. What is step 2? We should know in order to calculate my area, first I should know what are my inputs needed. I need length and breadth. So I'll write a simple line, a normal program like read inputs for length and breadth. Okay, first you are going to read your inputs for length and breadth. Okay. Then the third one is after I get my inputs of length and breadth, the next thing is I want to find the area of my rectangle. So what is the formula? I'll write. You call that phase as compute. Okay. Compute area x as length 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 into whatever I used that, right? Length into breadth. Now after I compute, what will I write? I will write a phase called as write. Write is output and read is input. So I'll write area. Then the fifth phase is stop. Okay. So this is the where you write your step-by-step procedure. So one second, please. Okay, once again I'm saying you. So you are finding area of a rectangle, right? So what I told, first step you are having in step 1, you are going to start. In step 2, we are going to read length and breadth. Okay. After you get your inputs, then you are going to compute the area. So compute area as length into, or you can write in more precise statement, compute area as the product of length into breadth. Okay, you can write it in that way. Then fourth one, after you compute that line, you are going to have a phase called as write. Your output is nothing but you are writing a statement, right? Area. Then the fifth phase is to stop. So this is a step-by-step procedure. So whenever a user, any new user is going to see this algorithm, he should understand how to write a basic program in order to find the area of a rectangle. Okay. Now the next one is you have your flowcharts. I told flowchart is nothing but you're calling it as a pictorial representation of an algorithm. So flowchart we call it as pictorial representation of algorithm. So pictorial representation of an algorithm, we are calling it as a flowchart. So understand. So in order to start, that is begin and end phase, we are using a symbol called as oval. Oval represents the start and end phase. Now, for example, in order to have the connectivity between the first line, like first step is to start, second step is to read. So in order to have that connection between the first step and the second step, we use something called as an arrow. It's nothing but you call it as a flow line, or they call some say that it as an arrow. So always your inputs and outputs will be taken. That is your read and write operations. Your read and write operations will be represented as an input and output, and that is taken by a symbol called as parallelogram. Okay, read write operations will be taken by a symbol called as parallelogram, and your instructions, that is your computational statements, like for example you have c equals to a plus b, or if you are writing n is equals to n by 10, all these are computational statements. Your computational statements will be represented with the help of a rectangle box. Okay, and you call that as a process, or you can also call that as a computational symbol. Computational symbol or a process is both mean same. So that for that you are going to use a symbol called as a rectangle. Now you will be using your if statements, right? So that is nothing but a decision making statement. Okay, like your if, while, all these you will be using a symbol called as a rhombus. Okay, so this is a decision making. As some say diamond, you can also call it as a rhombus, not not a problem. So rhombus, or you can call it as a diamond symbol, which is used for decision making notation. Now you can see this program, whichever we have written. Now for start, what I'm going to use, I'm going to use a oval symbol. Always remember in your flowcharts, we will be having only the symbolic representations. We don't use more part of writing your instructions. Okay, you see here. So start. Now the second line I should read L length and breadth. So I'll be using parallelogram. I'll write read L comma B. Okay, length and breadth I'm using a variable C. So then I have to compute. Whenever I say compute, I will be using a rectangle box. I'll write here, I'll just write the formula. Area implies, this is nothing but assignment. Like you write A is equals to, right? For equal to in flowchart and algorithm, we use this right side arrow mark, and I'll write L into B. Okay. After I get my area, what should I do? I have to print. That is nothing but you are writing right area. Then again I'll be using a parallelogram, and I will say write A. I'm using here A, so I'll be writing here A. Then the last phase is stop. So I'll write here the phase as stop. Understood, everyone? Okay. Do you want me to explain one more example with decision making symbol for algorithm and flowchart? Okay, yes, fine. I'll explain you. So you all understood this, right? So we'll do one decision making symbol. Okay. Okay. Someone is asking, so let me help them. For small example, I'll do. Okay. So we'll do small thing like to check number is negative or positive. Okay, we want to check whether the given number is negative or positive. So how many inputs we need? Only one, because you are only finding whether a given input is negative or positive. So first I'll write someone. Someone want a different example means you can ask me which question, which one you want me. I'll be going to explain that. Five 7K. You can ask me which question you want. Let me explain you that. Okay. Um, do one thing. Okay. So I'll be taking this small example now. So if anyone want any complex program algorithm to be written, you can ask me after this session. Okay. So you want to check a simple example, like you want to check whether the number is negative or positive. Okay. You need only one input. So what will I write? So first step is to start. Second step is to read a number. I'll read a number. After I read a number, here I have to use a decision, right? So I have to think whether number is positive. If a number is, I'll write in precise statement, that is, I'll write more clear, greater than or equal to 0, I say write positive. Okay. We use the other thing. We don't use else here. We write it as otherwise. Otherwise, write negative, and then you are going to use a phase called as the last one as stop. That's all. Now first start for this. Then what should I do? I have to read a number. So I'll be using a parallelogram now. Read some variable A. A is nothing but my number. Now after I get my input, decision making, I'll be using rhombus. So what I told, if number is greater than or equal, now I'll write symbolically. If A is greater than or equal to 0, what is he expecting you to write? It is a positive number. So I'll be using a parallelogram. I'll write positive number. This is, here you will be enclosing a statement called as true block. Now if this is false, you simply say write negative. Okay, now after you print write positive, you have to stop your program. So either this or this, you will be having a stop command. Okay, understood now everyone how to create your algorithms and flowcharts? Yes or no? Anyone has any doubt of doing this? Anyone want me to anyone has any doubt with this algorithm and flowchart? Everyone understood? Okay, so I feel that you all are clear with this concept. Then I'll go for the next one. Okay, okay, fine. Thank you. So let's do with the other question. So this is the yes. After you have your algorithm and flowchart, we have something called as program development. Okay, we also have the next phase, that is nothing but like system development. System development is purely different from program development. So in program development, what are the things which we use, or what are the things generally we use are, we have three things in program development. The first one is structure charts. Then you have pseudocodes or algorithms. So these are the things which generally we use. Pseudocode, or you have the something called as algorithms. So step-by-step procedure is an algorithm. Partial representation of your code, we call it as a pseudocode. And we also we also have structure charts, pseudocodes, algorithms, and the other one is flowcharts. As I explained you what are your algorithm and flowchart, only thing is you're left with structure charts. So what is a structure chart is? Actually, structure chart is used to design the whole program. Okay, it is also known as a hierarchy chart. Structure chart, you also can call it as generally in current we don't use most of your as a user we don't use this structure charts. Generally these are the things which are used by a design engineer. Okay, structure charts are used by your design engineers. What is the major difference between design built by a programmer and the design built by the engineer is the programmers is nothing but is that the programmer's product is software that will exist inside the computers, whereas the engineer's product is something that can be seen and touched. Okay, remember, as I told you, structure charts will be designed by a design engineer. So you may think, what is the difference between a program engineer and a design engineer is, program engineer always design which is used inside the computer, whereas a design engineer designs a software that will exist outside the computer. That is a thing or a product which can be seen and touched. That is hardwaring thing. Hardware you can take. A software thing is designed by a programmer, and hardware thing will be designed by a design engineer. So a structure chart will show how we are going to break our program into logical steps. Okay, and each step will be treated as like you write your functions, right? So how we are going to divide a big program into modules, that representation can be done with the help of your structure chart. Okay, so we are going to divide that so that we'll understand the interaction between, a better understanding can be achieved with the help of structure chart. That is how the interaction will be different, will be existing in between one module to another module. Okay, so this is very simple thing. First, structure charts will also be known as hierarchy charts. Generally, these structure charts will be used by a design engineer. Now, the difference between a soft program engineer and design engineer is, program engineer will design instructions which are inside the computer, and design engineer will design the instructions which are outside the computer, like which can be seen and touched. Okay, and what does the structure charts help is, always a structure chart shows how we are going to break our program into logical steps. That is, you'll be having different modules. And we design engineers, a program engineer will design the instructions which are used inside the computer, like your software. Now, what does a hardware engineer do is, hardware engineer designs the instructions which are used outside the computer, like your hardware devices. Now, what does a structure chart shows us? It shows us how we have to break our program into logical steps. That is, each step is treated as a module, and this also helps the interaction between, and it also clearly helps you to understand the interaction between one module to another module. Okay, so this is about your structure chart. Understood? Someone asked me this doubt actually. Any another doubt? Someone is asking, should we use double slash gram to representing loops? I didn't get you. 536, can you ask double? That is a comment line, right? You're asking. Loop means you're asking symbol? Yeah, no, no, no. Okay. No, it's not a parallelogram. For while loop, okay, for while and do while, you can use rhombus. Okay. For loop, we have angular rectangular box. This is specially for your for loop. Okay, for loop, we are going to use this box and it is called angular rectangular box. It is called as angular rectangular box. Fine. We don't use parallelogram, we use rhombus. Okay, fine, fine. Done. Okay, so the next important thing is we are entering into C concept. So these are the important things which we are having in chapter 1. So already chapter 1 notes is shared with you. Please go through them once. Once if you read, you will have an idea clearly how to write your exam. See, it is my handwritten notes which is shared. You have to write the points exactly according to that. That's enough. No need to refer any another textbook according to that. Enough whatever is shared by me. Okay, now let's talk about structure of C program. So see here, very important question. One second, someone is having some doubts. Ma'am, should we study testing methods for some? No, not needed, Prabhanjan. Okay, so we have the next important thing, that is nothing but structure of C program. Okay, you are entering into C. History of C is not been asked any time. Just you read the points like 919, how you are, okay, I'll explain you in a few lines how that history of C program came. So first what you will write is, it will be asked, it is never asked actually, but for your sake I'll explain you the history of C program. Then I'll talk about the structure of C program. Okay, so how actually C came is, the first computer programming language was, we have algorithmic language. This is the first basic programming language that has been designed. Like, it is used for structured programming. Okay, it will be used introducing the algol is a programming language, algorithmic language. It is a structured programming. This is the first programming language that has been introduced. Now, this structured programming is later in 1967, it has been converted to BCPL. Okay, that is nothing but basic computing or some say basic computing programming language, and some textbook says basic combined programming language. Okay, it is actually designed by Martin Richard in 1967. Algol was converted to BCPL. So later on, this programming language, to make more user friendly, in 1970 they have invented something called as B language. Okay, this B language, I mean BCPL is simply in 1970 they made it as B language by Ken Thompson. Finally, your B language with all high-end features of high-level programming language is being converted into C language in the year 1972 by Dennis Ritchie. Please. So first, the structure programming language was Algol language. How your evaluation came, I'm saying you history. Algorithm language was being converted into BCPL in the year 1967 by Richard. Okay. I think I don't actually his first. So he has converted this algol to BCPS. His name is Martin Richard. He have converted this algorithm language in the year 1967. So they have added additional features for BCPL. And Ken Thompson in the year 1970 he made that representation as B language. Now in 1972 the era of C language has been designed by Dennis Ritchie with all the high-level languaging features at Bell Laboratories. So this is a small evaluation of your C language. Okay. Now we will talk about how your C programming language structure is being designed. So we have different phases if you observe here. Okay. So they have made many phases for this to make more characteristically understand how your designing of structure have to be included. So the first phase they are calling it as a documentation phase. Okay, always a documentation phase makes you clearly understand what is your program or what is your program working for. What is you are going to design in document. Like for example, you are writing a program to find maximum of array elements. So the comment you are making, right, you will be having a comment section which is included in your documentation. So in your programming language of C, you have different comment lines. You can use double slash or you can use star slash followed by star and star followed by slash. This is begin of command and this is end of command. So this is used for multi-line comment section and this double slash is used for single line comment section. Okay, you can use this in both ways. Either you can use multi-line comment section and you can also use single line comment section. So documentation section always tells a user to understand what is this program working for. Okay, now next we have the next phase as your link section, and some say that documentation section is also author section. Who is going to design that program? That comment will be designed in your documentation. Next section is we have link section. Now when you see link section you will understand, okay, it consists of what? It consists or it provides some instructions to the compiler to link the functions from the system library. Like you will be writing, right, hash include something like stdlib.h. Okay, you will be including all your preprocessor commands. So please, these are not these, some people say library, but I say whenever you use this symbol you can call them as preprocessor commands. All your preprocessor commands which are needed for your program execution will be included under link section. Okay, all your preprocessor commands which are needed for your program execution will be included under link section. Now, the next one is definition section. What do we do in definition section? Can someone just guess? You will be writing different modules, right? Like whatever the like for example, if you are writing some functions, okay, you will be having user defined functions, right? You can write them, yes, exactly, and you will be having different macros like hash define, right? Hash define some parameter variable, all these lines, your hash define, yes, your macros, yes, it is also a but it is a user defined, it is a user defined macro function. So hash defined lines will be used in your definition section. Okay, all your macros can be included under your definition section. Then we have the next one as you can see global declaration. What do we have in global declaration? Always global declaration will talk about all the global variables which you want to define or which you want to use in your program. Okay, here your global variables or global functions can be used. Okay, in global declaration we are going to use your, so in global declaration we are going to use your global variables or global functions which are needed. Yes, you all know what is a global variable? A variable which can be used throughout your program. The lifetime is what? Throughout the program. Okay, so whenever you have any variable or any function to be used throughout the program, then we are going to use the func section, that is global declaration. Now the main thing is your main. So we all know that main is the starting where your program execution starts from which section? Main section. So we have two things here. We'll be having declaration parts and you'll be having an executable part. What is declaration part? Always a declaration part will declare the variables which must be used in your executable part. Now see, I will be writing int a comma b. I'm declaring here. Now this a comma b should be used in my execution phase, like this is sequence. In order to execute this line, I need to declare these variables first. So your declaration part will include all the variables which have to be used in your executable part. And always they have to be enclosed with between open and closed curly braces. Okay, that is about your function section of your main. And what is the subprogram section? These are your user defined functions. Like if you are writing any functions, okay, like you want to call one function from another function, all those subprogram sections will be included under main. The definition part of your program, user defined functions, will be included under subprogram section. Okay, so and one more thing, when you're writing about structure of C program, you also have to write few things like, so you also have to mention that all your statements should end with semicolon. Okay, that also can include. So once again, I'm explaining you. So in order to build a C program, these are the different sections that are involved, and you have to draw this chart. I mean this representation block diagram. So C program will be containing n number of sections. So the first section we are calling it as documentation section. In documentation section, what does we do? We include set of comment lines. This set of comment lines are designed for author specific. There is no rule that if I don't write comment, I can't run a C program. It is only depends upon your, so your comments can be enclosed between double slash or slash followed by star and star followed by slash. This is multi-line comment and this is single line comment. Now when you come to link section, in link section, what does we do is, link section provides instructions to the compilers, okay, to link all your system libraries like your preprocessor section. Now when you come to definition section, here we include all your macros definition like hash define, all those. And when you come to global declaration section will include all your global variables that can be used throughout the program. Okay, then the main function, this is the main thing that is very important program to execute. Your program execution begins from main. And one more point, always, okay, I'll ask me, main function is the begin of your program execution, which contains two parts. One is declaration and executable part. All the variables which are to be used in executable part will be declared in your declaration part. Okay, declaration part declares all the variables which are needed for your executable part. And also remember, it have to be enclosed between open and curl, and all your instructions should end with a semicolon. That also you need to write. Then we have the subprogram section, where in subprogram section we include all your user defined functions. Here, if they ask you structure of C program, you will draw this, you will explain, and you write a simple example for them. For everything, make a note. If they don't ask or don't ask, you write a simple example. That will be more helpful. Everyone understood the structure of C program? And one more point, who is calling main? That is very important. Main function is invoked by your operating system with help of system call. Yes, you need to write that point. Main method is invoked by operating system. Yes. Everyone understood now structure of C program? So try to yes. So we have one more left. Tomorrow we'll cover that. Then we can fastly cover all the concepts which are related to first unit. So I hope everyone understood with these concepts of today, like how to create and run your program, algorithms and flowcharts, and program development and structure of C program. Okay. Any doubt? You can message me personally. I'll just send you my number. Um, any doubt, you can just ask me in WhatsApp. Anything if you want, you can free